Welcome to Code Report. I'm your host, Connor Hoekstra. Let's take a look at the contest that happened last week.
We started off last week with Code Forces round 480 on Tuesday. Then we had the weekly Leak Code contest number 84 on Saturday evening. And just this morning, we had the Code Forces round 481 for the new Division 3. In addition to these three contests, we also had from Code Chef the May-long challenge continuing throughout the week. That contest ends, if you're watching this today, tomorrow at roughly 5 a.m. or Monday if you're not watching this today. Taking a look at our top 10 leaderboards, here they are. The two individuals that had top 10 finishes on multiple leaderboards were Yui, who placed 8th in the Code Forces round 480 and 1st in the Leak Code contest, and Natsugiri, who placed 10th in the Code Forces round 480 and 3rd in the Leak Code contest 84. In today's video, I'm going to be covering an alternative solution to problem 2 from the Hacker Earth May Easy 2018 contest entitled Sweets All Around. So I posted a solution to this problem yesterday, and then Dennis posted a comment saying that it sounds overly complicated. This is the most intersected interval, isn't it? Just shove everything into a vector of pairs and then sort by count and do a plus or minus depending on the begin or end. And I completely agree that this is a simpler solution, so much so that I thought it would be useful to do another video detailing the alternative solution, because I think this actually is a much better way to solve this problem and can inform other ways to solve other problems similar to this. So let's take a look at the problem statement. Students of Delhi Public School love sweets. They prefer eating sweets all the time. To make sure they remain happy, their math teacher Pramesh decided to get sweets for them. But since they are students of the Delhi Public School, they are not so easily pleased. A student will be happy if there are at least X sweets in the class and not more than Y sweets, because they know too many sweets could lead to diabetes. The teacher wants to buy the minimum number of candies so that the maximum number of students are happy in his class. Help him in finding out these values. And note that the number of students will be between 1 and 10 to the power of 5, and the number of candies which will satisfy the students will be between 1 and 10 to the power of 9. Note that X is always going to be less than Y. So let's take a look at the example that Hacker Earth provided us with. So this is the input that Hacker Earth provided us with, and for those of you that watched the video yesterday, the following visualization will look familiar. So we called the algorithm in yesterday's video the boundary sweep, and I would call this algorithm a boundary sweep as well. It's just a different implementation of it. So at the end of the day, both of them have the same time complexity, and they are very similar in the way they approach this problem. There's just a slight difference that sort of underlies the algorithm that enables us to implement it much easierly. And that is that we can decouple the relationship between the start and end of a range. So in yesterday's video, we used a multi-map to store the start and end for each range, and that meant the ranges were stored and kept intact. But we don't actually need to do this. We can separate them, and that enables us to just store them as a vector of pairs. And so the first value in our pair is going to represent either the number of candies at the beginning or end of the range, and then the second value in the pair is going to be a Boolean, which represents whether it's a start or end of the range. And then once we do this, we can just sort all these pairs and then do one pass over this vector of pairs, and every time we encounter the beginning of a range, we do a +1, and any time we encounter the end of the range, we do a -1. And then we can just keep track of a running sum, and at the point which we hit the maximum value of a running sum, that is going to be our answer. So what this will look like is that for each of these start of our ranges, we'll do a +1, +1, +1, and +1, and then for our ends, we'll do a -1. So there's a -2 here because 2 of our ranges for our orange and red student are ending. And if we calculate a running sum, we're going to end up with the following values, and our answer is going to be here. So the minimum number of candies that the teacher has to buy is 5, and that will end up satisfying 4 of the 5 students. So I think this is a much easier way to understand the problem and visualize the problem, and it also leads to slightly simpler code. So let's take a look at those solutions. So here we have our C++ solution. At the top of our main function, we're reading in n, which is the number of students. We are then declaring our vector of pairs, and we are initializing this to have size 2 times n, because for each student we will have 2 values. Then we're just reading in each of those values, and for the start of our range, we are setting the second value in our pair to be true, and we are setting the second value for the end of our range to be false. And note that we're passing in n plus 1, and that's because our range is inclusive. So we don't want to do the -1 until the end of our range. And so once we've read these in and stored them in our vector, we then sort our vector, and then we have our 3 integers x, y, which are going to be x is the minimum number of candies and y is the maximum number of students satisfied, and then sum is just going to be our running sum. And then we have our range-based for loop, and we're simply doing a plus equals to sum. We're adding 1 if we are looking at the end of our range or beginning of our range, and we are subtracting 1 if we are looking at the end of a range. And then we are just checking if our current sum is greater than our sum so far, reset our sum so far to be the current sum, and then set the number of candies to be equal to what we are looking at right now. And once we've finished this range-based for loop, we can then output our answer. So let's take a look at our Java solution. Slightly different from our C++ solution, and that's because Java 8 does not support any form of a pair or tuple. So we had to sort of make a slight modification. We're still at the top of our main function, reading in the number of students, and then instead of declaring a vector of pairs, we are declaring an array of doubles. And what we'll do is we are going to modify the value for the end of the range by adding a 0.5 to it. And what that will enable us to do is that when we're doing our calculation of our running sum, we can just do a modulus of double with the value of 1.0, and we can check to see if the result of this modulus is 0. And if it is, we know we're looking at the start of the range, and if it's not, we know that we are looking at the end of the range. So similar to the C++ solutions, we sort our array once we've read all the input in, we declare the same integers, and then we enter our for loop in which we will do our running sum calculation. So we do our plus equals. Here's our modulus calculation, checking to see whether it's equal to 0. If it is, we know it's the start of the range, add 1. If not, subtract 1. And then we do our same checks in our if statement here to reset our x and y values. And at the end, we just output. And moving on to our Python solution, here Python does not support pairs, but it does support tuples, so we can just use a list of tuples. Reading in our input is slightly different. We have to make sure to split the 2 integers that are on the same line, and then we can just make 2 calls to append. So this looks very similar to C++ here. Then we sort our list. We declare our integers x, y, and sum, and then we enter our for loop, and we do our plus equals either 1 or -1 based on whether this is the start or end of the range. And at the end, we just print out x and y again. So the last thing to talk about is our time complexity, and the time complexity here is going to be driven by our sort function, and we know that the sort function has a time complexity of n log n. Taking a look at the contests that are happening next week, we have a pretty busy week with 7 contests in total. We have 3 contests from Codeforces round 42, 43, and 44 happening on Monday, Tuesday, and Thursday respectively. We have the SRM 734 contest happening on Wednesday night from Topcoder. We have the start of the Hacker Earth Maze Circuits contest, which starts on Saturday morning and lasts for 9 days. We have the weekly LeetCode contest number 85 happening on Saturday evening, of course. And finally, on Sunday, we have the Code Chef May Cook-Off.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.